Assalamu alaikum. My name is Sajid, and in this explanation lecture, we'll go through the A-Level Physics 9702, Paper 1 of the Fastpapers Mock Championship 2026. Right, so starting off with the first question. Which expression has the same SI base units as pressure? Okay, we have four options here. Now, pressure is equal to force over area. Now, force is equal to mass times acceleration, right? So the SI base unit for force would be kg meters per second square, kg meter per second square, mass times acceleration. This is the SI base unit of force. Now, pressure is equal to kg meter per second square, force divided by area, divided by area. Now, the SI base unit for area would be meter square, right? Meter square. Now, overall, that gives us kg meter divided by meter square second square. If we just, you know, remove this division sign with a multiplication sign, we get a reciprocal of the meter square. So if we remove the meters from the numerator and the denominator, we get kg per meter second square, which is mass over length times time square. Mass divided by length times time square. So the answer would be C. What is an approximate value for the speed of sound in air? Okay, 300 meters per second. Answer is B. A pendulum bob is held stationary by a horizontal force H. The three forces acting on the bob are shown in the diagram. Tension H and W. The tension in the string of the pendulum is T. The weight of the pendulum bob is W, and the string is held at an angle of 30 degrees to the vertical. Which statement is correct? Okay, so if this holding is in equilibrium, there has to be a force vertically upwards, which is balancing out the force of the weight. And there also has to be a force acting towards the left, which is balancing the force H. This vertical force is the vertical component of the tension, and this horizontal force is the horizontal component of tension. Now, if we assume a triangle with a 30-degree angle here, and the hypotenuse as tension T, the vertical component of this tension will be T cos theta, which is cosine of 30, and the horizontal component will be T sine 30, which means the horizontal component of tension will be equal to H. H is equal to T sine of 30. And the vertical component of tension will be equal to W, the weight. W is equal to T cosine of 30. So the only option that matches our conclusion is option D. So the answer is D. A student is investigating an electrical signal using a CRO. The frequency of the signal is 50 kilohertz. Which time-based setting on the oscilloscope should be used? Okay, so a frequency of 50 kilohertz is 50,000 waves in 1 second. 1 second, okay, which means 1 second will have 1 over 50,000 waves. That's the time period. So the time period is 1 over 50,000, which is 20 microseconds. Now, if our time-based setting is 50 milliseconds, that would have like 2,500 waves in 1 centimeter, in a 1 centimeter block. If the time-based setting is 1 millisecond per centimeter, it's going to have about 50 waves in a 1 centimeter block, which is both of these options have way too many waves in 1 centimeters, right? So option A and option B won't really work. If the time-based setting is 10 microseconds per centimeter, we need 2 blocks to show 1 complete wave, right? So option C makes sense. And as for option D, if the time-based setting is set to 0.5 microsecond per centimeter, that's going to require like 40 centimeters of space or 40 centimeter blocks to show one single wave, right? So option D also does not work. A student wishes to measure a distance of about 10 centimeters to a precision of 0.01 centimeters. Which measuring instrument should be used? Okay, so a meter rule generally has a precision of 0.1 centimeters, so that won't work. Meter rule and tape measure both have the same precision. So so option B and D are the only ones that make sense. Both micrometer and vernier caliper can measure up to a precision of 0.01 centimeters. But a micrometer screw gauge cannot measure up to 10 centimeters, which means a vernier caliper should be used. A CRO is connected to an alternating voltage. The following trace is produced on the screen. The oscilloscope time-based setting is 0.5 milliseconds per centimeter and the Y plate sensitivity is 2 volts per centimeter. Which statement about the alternating voltage is correct? The amplitude is 3.5 centimeters. Okay, amplitude cannot be 3.5 centimeters because the Y plate sensitivity is in volts, right? So whatever it is, the unit of amplitude will definitely not be centimeters. So it's not option A. The frequency is 0.5 kilohertz. Okay, so for that, let's find out the time period. The time period is 1, 2, 3, and 4. 4 blocks, right? Now, 4 blocks is equivalent to 4 times 0.5 milliseconds. 0.5 milliseconds, which is 2 milliseconds. That's the time period. So if the time period is 2 milliseconds, frequency is going to be 1 over 2 milliseconds. Converting it to seconds gives us 10 to the power of minus 3, which is about 500 hertz. And 500 hertz is 0.5 kilohertz. So yeah, option B is correct. Let's check the other options. The period is 1 milliseconds. Nope. The time period is 2 milliseconds. And the wavelength is 4 centimeters. Nope. Wavelength cannot be measured from here. We are measuring the x-axis of this whole grid is time. So it doesn't show us the wavelength. Answer is B. A stone of mass m is dropped from a tall building. There is significant air resistance. The acceleration of free fall is g. When the stone is falling at a constant terminal velocity, which information is correct? Magnitude of acceleration of the stone. So acceleration would be 0 because it's moving at a constant velocity. So that rules out option A. Magnitude of the force of gravity on the stone. Okay, the force of gravity will always be mg, which means our answer should be either B or D. Magnitude of the force of air resistance on the stone. Okay, now if it's in equilibrium, the force of gravity or the weight of the object should be equal to the air resistance, which means the air resistance will also be mg, meaning B is our answer. The velocity time graph for an object is shown. How can the total displacement of the object be determined? Okay, so the total displacement can be found from the area under a velocity time graph. So area 1 is some amount of displacement covered and area 2 is another amount of displacement covered but in the opposite direction. So area 1 will be positive and area 2 will be negative if we consider this top portion as positive. So the displacement covered will be area 1 minus area 2, giving A as our answer. A girl throws a ball vertically upwards. It takes a time of 3.20 seconds to return to her hand. Assume air resistance is negligible. What is the initial speed with which the ball is thrown? Okay. So here we can apply the Suvat equations. Right. Now, since the ball returns to her hand, the displacement covered, S, will be equal to 0 because it returns to the same point as it initially was. The initial velocity is what we have to find. U is the variable that we want to determine. And since it's moving vertically, acceleration will always be minus 9.81 gravitational acceleration. And we are also given a time of 3.20 seconds. Time is 3.20 seconds. Now, since we have these three quantities, S, A, and T, we can find out the value of U, initial velocity, using the equation S is equal to UT plus half AT square where S is 0, U is the quantity we're trying to find, times time, which is 3.20 seconds, plus half times acceleration is minus 9.81, and the value of time is 3.20 squared. So if we make U the subject, it gives us a value of 15.696 and so on, which it can be approximately written as 15.7, which is closest to C. So the answer to question 9 will be C, 15.7 meters per second. Steel pellets, each with a mass of 0.60 grams, fall vertically onto a horizontal plate at a rate of 100 pellets per minute. They strike the plate with a velocity of 50 meters per second and rebound with a velocity of 40 meters per second. What is the average force exerted on the plate by the pellets? Okay, so here we are given the mass of each pellet and the rate at which the pellets fall on the plate. We're also given the initial and final velocity of the pellets. Okay, so force, we know force is equal to the change in momentum per unit time, mv minus mu over time. Now, force would be equal to the total mass of the pellets that drop on the plate per second. Okay, so if 100 pellets fall per minute, how many pellets do we have per second? Let's do that question here. All right, so we got 100 pellets in 60 seconds. So in 1 second, we have 100 over 60 pellets. That's in 1 second, we have 100 over 60 times 0.6, which is the mass of each pellet, times 10 to the power of minus 3 kg. This is the amount of mass that drops on the plate per second. So the average force would be the mass, which is 100 over 60 times 0.6 times 10 to the power of minus 3. Mass times the change in velocity, which is 5 meters per second minus 4 meters per second. Okay, now one thing to notice is the initial velocity was 5 meters per second, which means 5 meters per second dropped on a pellet, and 4 meters per second, uh, 4 meters per second is the rebound velocity, 5 and 4, which means the 4 here should be negative because it's in the opposite direction, right? So 5 minus 4 means basically 5 plus 4, right? So that gives us mass times the change in velocity over time. And since we're assuming the mass dropped on a pellet per second, the time will be 1 second. So the average force exerted on the plate would be 0.009 newtons. So the answer would be C. A ball falls through a liquid at a constant speed. It is acted upon by three forces: an upthrust, a drag force, and its weight. Which statement is correct? Okay, so a ball falls through a liquid at constant speed. So assuming this is the ball falling into the liquid, it has its weight acting downwards. It has an upthrust acting upwards and drag force acting upwards. Okay, so the statements are: the drag force increases with increasing depth. No, because drag force depends on the velocity, it does not depend on the depth. The drag force is equal to the sum of the upthrust and the weight. Drag force is equal to the sum of the upthrust and the weight. No. Weight is equal to the sum of the upthrust and drag. So both of these are wrong. The upthrust is constant with increasing depth. Okay, this sort of makes sense. The weight is greater than the sum of the drag force and the upthrust. Nope, because the weight has to be equal to both of these, otherwise it would not be in equilibrium. Okay, that means C is our answer. Why? Because upthrust stays constant. Upthrust depends on the volume of the liquid that is displaced, right? So if we assume this is the surface of the liquid, and if the ball is completely submerged inside the liquid, no matter how much it falls through the liquid, it's not going to displace more volume of liquid than it already did after it became submerged, right? So the upthrust sort of remains constant with depth because the volume of displaced liquid does not increase with the depth. So C is our answer. A fairground ride consists of 4 carriages connected to a central vertical pole as shown in the following view from above. A motor rotates the central pole about its axis. This results in the 4 carriages each moving along a circular path. The distance from the middle of each carriage to the center of the pole is 3.2 meters. Distance from the middle of each carriage to the center of the pole. Okay, so this distance right here is 3.2 meters. When they are moving, each carriage experiences an air resistance of 85 newtons. Assume that there are no other significant resistive forces. Which torque does the motor need to apply to the pole to keep the system rotating at constant maximum speed? Okay, so for this to rotate at constant maximum speed, the force here, force of rotation over here, should be equal to the air resistance, right? Which means this force here provided by the motor should be equal to 85 newtons. Okay, now we need to find the torque provided by the motor. So torque would be equal to the force, which is 85 times, okay, we have the same amount of force in both of these carriages, right? 85 over here and 85 newtons over here. So the torque would be 85 times the total distance from here all the way here, from one carriage to the next carriage, which is 3.2 times 2. This is the amount of torque provided to two of these carriages on this one single line, on this line. Okay, so the total torque that needs to be provided by the motor should be twice the torque calculated over here, right? Because we have 4 carriages times 2. Okay, so this is the torque that needs to be provided to 2 of these carriages. So that multiplied by 2 is the torque provided to all 4 carriages, which gives us a value of 1088, which is approximately 1090. The answer would be D. A uniform horizontal beam OX 4 meters long and weighing 100 newtons is hinged at a wall at point O. It is supported by a cord XY which is attached to the wall at Y. Okay, what is the tension in the cord? So this beam has a weight of 100 newtons acting at the center of mass. The distance from point O to the center of mass is half of 4, which is 2 meters. Now this force or this moment is being balanced by the vertical moment of this tension of the cord. So the principle of moment would be something like this: 100 newtons times 2 is equal to, let's call this TV, vertical component of the tension, TV times 4. So the vertical component of tension would be 100 times 2 divided by 4. Okay. Oops, should be a straight line. Yeah. Okay, now if this angle right here is 30 degrees and this vertical component of tension is 100 times 2 divided by 4, the tension right here, T, should be equal to, we can use the sine trigonometric ratio, sine 30 is equal to 100 times 2 divided by 4 is 50. 50 over hypotenuse T. So T will be equal to 50 over sine 30, which is about 100 newtons. An object shaped as a hemisphere rests with its flat surface on a table. The object has radius r and density rho. The volume of a sphere is given here. Which average pressure does the object exert on the table? Okay, now pressure is force over area, and force in this case will be the weight of the object. Okay, so to find the weight, we need to find the mass, right? Mass in terms of density and volume is density multiplied by the volume. Density is given in rho, and the volume is 4 by 3 pi r cube. Now, there's a catch. The volume of a sphere is 4 by 3 pi r cube, but the volume of a hemisphere, which is half a sphere, will be 4 by 3 pi r cube divided by 2, right? Which is 4 over 6 pi r cube. This is the mass of the object. So the weight will be equal to mass times gravitational acceleration, which is density times volume times g. This is the weight of the object. Now, the area, okay, so this right here is a hemisphere, right? So the cross-sectional area of this hemisphere will be a circle. The cross-section of a sphere is a circle, right? So the area is area of a circle by r square. So force by area, which is pressure, will be equal to rho times 4 by 6 is 2 by 3, 2 by 3 pi r cube times g. This is the force or the weight divided by the area pi r square. We can remove the pi from here and r from here, which leaves us with 2 by 3 rho times g. Oh, there is also an r over here, the radius. I forgot about that. So 2 by 3 rho times r times g, rho times r times g. Yeah, d is our answer. Which statement best represents the principle of conservation of energy? Okay. Energy cannot be used faster than it is created. Nope. This makes no sense. The supply of energy is limited, so energy must be conserved. No, that is not what conserved means over here. The total energy in a closed system is constant. Okay, this makes sense. The total energy input to a system is equal to the useful energy output. No. This is no. D does not make sense because useful energy output is almost always less than the energy input, total energy input. So our answer will be D. In a closed system, the total energy remains constant. A sledge of mass 100 kg sits on a snowy surface. It is pulled horizontally for 20 meters against a frictional force of 400 newtons. Then it is pulled horizontally across ice for 20 meters. There is no friction between the ice and the sledge. It is lifted up vertically by 2 meters and finally carried back at a constant speed to where it started. Okay. During which stage of its journey is most work done on the sledge? Okay, so there are 3 parts of this journey. The first part is moving on snow. So this part is 20 meters long. The next part is moving on ice, which is also 20 meters. And the third part of the journey is the sledge moved vertically up by 2 meters and carried back. So the distance here is 40 meters. Okay, now, so option A says being carried back 40 meters at constant speed, B is being lifted up 2 meters, C is being pulled 20 meters across ice, and D is being pulled 20 meters across snow. Okay, so during the snowy part of the journey, there is a frictional force in the opposite direction of 400 newtons. So the work done against friction, work done is force times the distance. The frictional force is 400 and the distance is 20, which is 4 times 2, 8,000 joules. 8,000 joules is the work done against friction in the first part of the journey. In the second part of the journey, there is no resistive forces, so the work done here is equal to 0 because there is no work done against any resistive forces. In the third part, okay, so there are 4 parts of this entire journey, and one of these 4 parts is being lifted up by 2 meters. And the work done in being lifted up by 2 meters is mgh, which is gravitational potential energy. So here, the mass is 100, g is 9.81 times 2 meters, which is approximately 2000. Actually, it's 1962 joules. And in the fourth part of the journey, again, the work done is 0 because it's being carried 40 meters without any resistive forces. So the most work is done by the first part of the journey, being carried 20 meters on snow. So the answer would be D, being pulled 20 meters across snow. An object is moved in a vertical plane from X to Y and then from Y to Z as shown in the diagram. The distances between various points are indicated on the diagram. Lines x, y, and v, z are vertical. X, y, and v, z are vertical. The object weighs 20 newtons. How much gravitational potential energy does the object gain by moving from x to z? Okay, from x, this point right here, to z, this point right here. Okay, so when moving from x to z, the change in height is simply 3 meters. It doesn't matter how far below it goes. It doesn't matter what the diagonal distance is or the horizontal distance. So the diagonal and the horizontal distances don't really matter. What matters is the height gained by the object when moving from x to z. So when moving from x to z, it moves by a vertical distance of 3 meters. So gravitational potential energy would be the mass, which is, okay, we don't know the mass, but we know the weight of the object, which is 20. Now, in mgh, in the formula mgh, mass times gravitational acceleration is the weight of the object, right? So weight of the object times 3 is the gravitational potential energy gained, which is 20 times 3, 60. Answer would be A. A car travels at a constant speed of 25 meters per second up a slope. The wheels driven by the engine exert a forward force of 3000 newtons. The total force due to air resistance and friction is 2100 newtons. The weight of the car has a component down the slope of 900 newtons. What is the rate at which thermal energy is dissipated? Okay, so the object, the car, travels up a slope at a constant velocity of 25 meters per second. The forward force is 3000 newtons, and force due to friction and air resistance is 2100 newtons, and the component of the weight is 900 newtons. Right. We need to find the rate at which thermal energy is dissipated, which means the thermal energy produced by one of these forces. Okay. Now the 3000 Newton force is the force required, is the force given to the car to move it forward. And the 900 newtons is simply the component of the weight. It's not quite converted to heat energy. The resistive forces, however, due to air resistance and friction, is converted to thermal energy. So thermal energy or heat will be equal to energy is force times velocity. The force 2100 times velocity 25, which is equal to 52,500, which can be rounded to 53 times 10 to the power of 3. The answer would be C, 5.3 times 10 to the power of 4. 53 times 10 to the power of 3 is 5.3 times 10 to the power of 4. A composite rod is made by attaching a glass-reinforced plastic rod and a nylon rod end to end, as shown. The rods have the same cross-sectional area and each rod is 1 meter in length. The Young modulus EP of the plastic is 40 gigapascals and the Young modulus En of the nylon is 2.0 gigapascals. The composite rod will break when its total extension reaches 3 millimeters. What is the greatest tensile strength that can be applied to the composite rod before it breaks? Okay, so Young modulus E is stress over strain. Over strain. Okay, now stress is the quantity we're trying to find, the greatest stress for which the rods will break. So if we make stress the subject, let's call it S, will be equal to Young modulus times strain. Now strain is extension over the original length, and the maximum extension that the composite rod can take is 3 millimeters. Okay, now there are two rods with Young modulus EP and En. Let's say for EP, the stress is EP times, let's say the extension is x1 divided by, let's say the original length of the glass reinforced plastic is L1. This is stress given to the glass reinforced plastic. Let's say S2 is the stress given to the nylon rod. Stress will be equal to Young's modulus En times the extension, let's say this is extension 2, divided by the original length of the nylon. Let's call it L2. Okay, so the composite rod will break when the total extension reaches 3 millimeters, which means the total extension, the sum of the extension of the glass reinforced plastic plus the extension of the nylon should be 3 when the rod breaks. So x1 plus x2 is the extension when the rod breaks. Okay, now if we make x1 and x2 the subject, we get x1 is equal to S1 times L1 divided by EP, and x2 is equal to S2 times L2 divided by En. So x1 plus x2, the total extension of the two rods will be equal to the stress S1 times L1 divided by En plus S2 times L2 divided by EP. Sorry, this will be EP and this one is going to be En. Okay, now we know the original lengths of the two rods. Both of them are 1 meters, and the stress is going to be equal on both the rods. So instead of writing S1 and S2, we can simply remove that and call it S, because for both of these rods the stress is equal. We know the Young's modulus of both of these rods, so we know these two denominators, and we also know the maximum extension of the two rods, which is 3 millimeters. X1 plus X2 will be 3. So 3 is equal to S times 1 divided by 40 times 10 to the power of 9 gigapascals. Giga is 9, plus S times 1 divided by 2 times 10 to the power of 9 gigapascals. So if we make S the subject from this equation, we get something around 5.7 times 10 to the power of 6 pascals. So the answer would be B. The logic behind this question is, we know that the total extension, the maximum total extension of this composite rod is 3 millimeters. So we take individual extensions of these two rods, the glass reinforced plastic and the nylon, as two variables, x1 and x2, and we find the individual extensions, x1 and x2, in terms of the stress. So x1, the extension of this rod, will be equal to the stress provided to this rod times its original length divided by the Young's modulus, and the extension of the nylon rod will be the stress provided to this rod multiplied by the original length divided by the Young's modulus En of the nylon rod. Then if we add up x1 and x2, we get an equation that looks like this. Since we already know x1 plus x2 is 3 millimeters, we equate that in the place of x1 and x2. And then we simply make S, which is stress, we make S the subject to get the answer. The graph shows the nonlinear force extension curve for a wire made from a composite material. What is the best estimate of the work done in stretching the wire to point B? Okay, so this right here is a curve, and the area under this curve is the work done in stretching the wire to the point B. So what we can simply do is find the area of the triangle that joins the points 0, the origin, and the point B. The area of the triangle would be half times the base, which is 2 millimeters times 10 to the power of minus 3 times the height, 100. This gives us a work done of 0.10 joules. Okay, this work done is actually an underestimate because we are not accounting for this area which falls between the curve and the straight line. So the area has to be slightly larger than this, slightly larger than 0.10, which would be C right here, 0.11 joules. The variation of the compression of a spring with the force applied to it is shown in the graph. The block slides along a horizontal frictionless surface towards the spring as shown. The block is brought to rest by the spring. When the spring reaches a compression of 4 centimeters, all of the kinetic energy of the block is transferred to the elastic potential energy of the spring. What is the kinetic energy of the block when it first makes contact with the spring? Okay, so a compression of 4 centimeters. When the compression is 4 centimeters, right over here, the force is 8 newtons. At this point, the elastic potential energy stored in the spring would be area under the graph, half times the base, which is 8 newtons, times the compression, which is 4 centimeters. 4 times 10 to the power of minus 2 meters. The answer here would be 0.16 joules. Now this is the amount of work done by the block to compress the spring. So the kinetic energy, initial kinetic energy of the block would be 0.16 A. A longitudinal wave travels through a long spring. The spring is shown at one instant. What is the wavelength of the wave? Okay, so for a longitudinal wave, the wavelength is the distance between two compressions or two rarefactions. So this length right here is the wavelength, or if we have another rarefaction here, this length would be the wavelength. Both of them are equal. So option A is the distance between one compression and one rarefaction. So that won't be the answer. Option D is the distance between one compression to the next compression. So the answer is B. It cannot be C because C is the distance from one compression to the next rarefaction. And option D is basically twice the wavelength. So D is also not the answer. Answer would be B. A sound wave has a frequency of 3000 Hz and a speed of 1200 meters per second. What is the shortest distance from a point of maximum pressure in the wave to a point of minimum pressure? Okay, so point of maximum pressure is a compression and a point of minimum pressure is a rarefaction. We know the frequency of the wave and the speed of the wave. From these two quantities, we can find out the wavelength of the wave. C is equal to F times lambda. So lambda would be equal to lambda, which is the wavelength, is equal to speed divided by frequency, which is 1200 meters per second divided by 3000 Hertz. The wavelength here is 0.4 meters. Now, the distance between a maximum pressure and a point of minimum pressure is the distance between a compression and a rarefaction, which is half times the wavelength, right? The wavelength is one compression to another compression. So this distance right here will be half of a wavelength, which is 0.4 divided by 2, 0.2 meters. Option B. A sound wave is displayed on the screen of a CRO as shown. The time base of the CRO is set at 2.5 milliseconds per centimeter. What is the frequency of the wave? Okay, so the time period of this wave is 1, 2, 3, and 4. 4 boxes, right? So 4 boxes times 2.5 milliseconds per centimeter. So the time period is 4 times 2.5 times 10 to the power of minus 3 seconds, and 1 by time period, the inverse of time period is the frequency. Frequency would be 1 over 4 times 2.5 times 10 to the power minus 3, which is 100 Hertz. Option B. A car traveling in a straight line at a speed of 30 meters per second passes near a stationary observer while sounding its horn. The true frequency of sound from the horn is 400 Hertz. The speed of sound in air is 336 meters per second. What is the change in the frequency of the sound heard by the observer as the car passes? Okay. So a car approaches the observer and then it passes the observer. So when a car approaches the observer, the frequency heard by the observer would be F0. This is basically a Doppler effect problem. Now, if we apply that formula, F0, F0, Fo, which is frequency heard by the observer, is the frequency of the source times the speed of the wave divided by speed of the wave plus minus speed of the source. So when the car approaches the observer, FO is going to be frequency of the source, which is 400, times speed of the wave, 336, divided by 336, V minus the speed of the source, 30. That's equal to about 439 hertz. Now, in the same equation, if we replace the negative with a positive, we get FO is equal to 400 times 336 divided by 336 plus 30. That gives us 367. So 439 minus 367 is the range or the change in frequency of the sound heard by the observer, which is 72 hertz. The range is 72 hertz, 367 to 439. So the answer is C. A pipe closed at one end has a loudspeaker at the open end. A stationary wave is formed in the air within the pipe with an antinode at the open end of the pipe. The length of the pipe is 0.85 meters. The speed of sound in air is 340 meters per second. Which frequency of sound from the loudspeaker would not produce a stationary wave? Okay, so it forms an antinode at the open end. So if it forms an antinode at the open end, it has to form a node at this closed end of the pipe, right? So in a stationary wave, these points of zero displacement are nodes, and the points of maximum displacement are the antinodes. Okay, so antinodes in a wave are formed if this distance is the wavelength. Nodes are formed at 1/4 of wavelength, which is 0.25 basically, 1/4 of lambda, and they're also formed right over here, which is 3/4 or 3/4 of a wavelength. Antinodes are formed at 1/4 of a wavelength and 3/4 of a wavelength. Okay, so out of these four frequencies, we need to find out which one of these frequencies, basically which one of these waves has a wavelength that completes an integer number of waves plus a quarter of a wavelength. Sorry, that will be 4. Or an integer number of waves plus 3/4 of a wavelength. So basically, if the number of waves formed within this pipe is something 0.25, it forms an antinode at these two ends, or if it's something 0.75, it forms an antinode at these two ends. Okay, so lambda is C by F wavelength. So for option A, actually, let's not look at it that way. The length of this pipe is 0.85 meters. So if it's 0.5 meters, let's suppose we find the wavelength of the wave at A, 100 hertz. If it has, our purpose is to find out whether it has a quarter of a wavelength or 3/4 of a wavelength or not, right? So 0.85, which is the length of the pipe, divided by lambda gives us number of waves. Inside the pipe. So 0.85 divided by C, which is the speed of sound, 340, divided by F, the frequency, 100, gives us the number of waves inside this pipe. For option A, that number is 0.25, meaning for option A wave with a frequency of 100 hertz produces 1/4 of a wavelength inside this pipe. So A is definitely not the answer. For option B, the number of waves formed is 0.5, which makes sense because it forms 0.5 waves. So at this point right here, the open ends, it's not going to form an antinode. It's going to form a node, which is half the wavelength. So the answer would be option B. For option C, we get a value of 0.75, which is 3/4 of a wave. So this wave right here will form an antinode at the open ends, and option D is 1.25. So what that means is a 500 hertz wave will form one complete cycle and 0.25 of a wave, one complete cycle and then 0.25 of a wave at this point right here. So option D also forms an antinode. The answer is B. The diagram shows two sources of waves, S1 and S2. The sources oscillate with a phase difference of 180 degrees. The sources each generate a wave of wavelength 2 centimeters. Each source produces a wave that has amplitude x0 when it reaches point P. What is the amplitude of the oscillation at P? Okay, so they both have a wavelength of 2 centimeters. So S1, let's find out the number of waves made by S1. Now the number of complete cycles for S1 would be the total distance, 5 centimeters, divided by the wavelength, 2 centimeters, which is 2.5. S2 forms 13 over 2 waves, which is 6.5 waves. So basically what that implies is from S1 to P, we have 2 waves and half a wave, and from S2 to P, we have 6 waves, 6 waves and then 0.5 of a wave. Okay, now one thing to notice is that the phase difference between S1 and S2 is 180 degrees, which means S2 will start from a phase of 180 degrees compared relative to S1, and it will also end with a phase difference of 180 degrees compared to S1. So the phase at this point from S1 to P and at this point from S2 to P are both 180 degrees apart, right? Which means the interference or the interference between these two is destructive interference. So the wavelength of the two will cancel out and become 0. The answer is A. A two-source interference experiment uses the apparatus shown. What is the main purpose of this single slit? Okay. The single slit is used to provide a coherent source of light. Answer is C. The diagram shows a stationary wave at time t equal to 0 that has been set up on a string fixed between points P and S. The nodes of the stationary wave occur on the string at points P, Q, R, and S. The nodes occur at these 4 points. Point X is moving down at time t equal to 0. X is moving down. The points on the string vibrate with time period t. Okay, and maximum amplitude of 2 centimeters. The displacement S is positive in the upward direction. Okay, so the upward direction is positive. Which graph best shows the variation with t of the displacement S of points y on the string? Okay. Now these 4 points P, Q, R, and S are nodes, which means these are the points of uh, zero displacement. If X moves down, the wave at this instant of time looks like this. Where P, Q, R, and S are all nodes. So from this, we can clearly see that if point X moves downwards, point Y will also move downwards because these two are 2 nodes apart. Now, Y has to move downwards, right? That automatically rules out option C and option D. So the correct answer will be either A or B. Now, this point right here, Y, is not at the center of 2 nodes, which means Y does not form an antinode. If it was at the center of R and S, it would have formed an antinode, and the maximum displacement here would have been 2 centimeters. But since point Y is not at the center, it's closer to R, the maximum displacement of Y will be less than 2. So the answer will be A, option A. The point Y will never actually be able to reach 2 centimeters. The current I in a metal wire is given by the expression I is equal to ANVQ. What does the symbol N represent? N is the number density of free electrons. So let's check the options. The number of atoms per unit volume. Okay, it's not the number of atoms. The number of free electrons per atom in the metal. Per atom? Nope, it's not the number of electrons per free electrons per atom, it's the number of free electrons per unit volume of the metal. So not option B. The number of free electrons per unit volume of the metal. Yep, that sounds like the correct answer. The answer should be C. Let's check the option D just for good measure. The total number of electrons per unit volume of the metal. Okay, so it's not the total number of electrons per unit volume, it's the total number of free electrons. Okay, what is the unit of resistivity? We are familiar with the equation R is equal to resistivity rho times L length divided by cross-sectional area A. If we make rho the subject, resistivity will be equal to resistance times area over length. Resistance has a unit of ohm, area has a unit of meter square, length has a unit of meter. So overall we get the unit of rho as ohm times meter, ohm meter, option D. A cylindrical wire has cross-sectional area A and number density of free electrons n. The wire has current I and free electrons have average drift speed v. A second cylindrical wire has cross-sectional area 0.5 A and number density of free electrons 2n. In this wire, the free electrons have average drift speed 2v. What is the current in the second wire? Okay, so here we need to find the current of the second wire, I, let's call it I2. So the current in the first wire is equal to I is equal to N number density times A cross-sectional area times drift speed times the elementary charge E. I2 here would be equal to 2N times cross-sectional area 0.5 A times drift speed of 2v times elementary charge E. Okay, so from these two equations, E, the elementary charge, is constant. So if we equate both of these for E, the first E here will be equal to I over N times A times V, and E over here is going to be I2 divided by 2N times 0.5 times 2V. So I1 divided by N times A times V is equal to I2 divided by 2N times 0.5 A times 2V. There's going to be an A over here. Okay. Now, if we write I2 in terms of I1, it's not actually I1, it's just I. If we write in I2 in terms of I, it's going to be I2 is equal to I times 2N times 0.5 A times 2V over N times A times V. So now we can simply remove all of these quantities. That leaves us with I2 is equal to I1 or I times 2 times 0.5 times 2. Half of 2 is 1 and 2 times 1 is 2. So the second current is equal to twice of I. Answer would be C. The resistance of a metal cube is measured by placing it between two parallel plates as shown. The cube has volume V and is made of a material with resistivity ρ. The connections to the cube have negligible resistance. Which expression gives the electrical resistance of the metal cube between X and Y? Okay. The resistance here is written in terms of the resistivity and the volume. We know that resistance R is equal to resistivity times length over the area. Now we know that the volume of a cube is V is equal to length cube, L cube, right? So writing L in terms of V gives us L is equal to cube root of V, which is V to the power of 1/3. We now also need the area in terms of V, right? So area is length square. Length written in terms of volume is V to the power of 1/3. So area will be V to the power of 1/3 whole square, which is V to the power of 2/3. So rho L over A would be rho times V to the power of 1/3 divided by V to the power of 2/3. Okay, now if we rearrange this equation, it gives us rho times V to the power of 1/3 minus 2/3, right? So resistance R will be equal to rho times V to the power of 1 by 3 minus 2 by 3 is minus 1 by 3. That simply gets rearranged to rho divided by V to the power of 1/3. The answer would be C, rho divided by V to the power of 1/3. A cell with internal resistance is connected to a light-dependent resistor LDR, a fixed resistor, and a voltmeter, as shown here. The voltmeter reading increases. Which quantity decreases as the voltmeter reading increases? Okay, so which quantity decreases as the voltmeter reading increases? Now, if the voltmeter reading increases, the potential difference across the fixed resistor increases, right? So let's call that VF, voltage across the fixed resistor. Now, if the voltage across the fixed resistor increases, the only way to increase the voltage across this resistor is by decreasing the resistance of the LDR, because this resistor right here is fixed and the internal resistance is also fixed. These two cannot change. So to increase the potential difference across this resistor, the only method is to reduce the resistance of the LDR. So let's say R LDR, that's the resistance of the LDR. If VF increases, resistance of the LDR decreases. Okay, let's check the options first. The charge moving through the cell per unit time. Okay, so if the resistance of the LDR decreases, the overall resistance of the circuit decreases, right? If the resistance of the circuit decreases, the current flowing through the circuit increases. The current has to increase. Now, charge moving per unit time is current. Since the current increases, A cannot be the answer. The energy transferred to the fixed resistor per unit time. Okay, so energy transferred to the fixed resistor, oh sorry, not per unit time, it's per unit charge. So energy transferred to the fixed resistor per unit charge is simply the potential difference across this resistor. Voltage is energy carried per unit charge. So this quantity right here increases as stated in the question. So the answer cannot be B. The intensity of light on the LDR. Okay, so if if the intensity of light decreases, the value of R, or resistance of the LDR, will increase. If light decreases, resistance will increase. So that is not what happens, because we've already concluded that the resistance of the LDR decreases, which means the intensity of light increases. That leaves us with D as the correct option. The terminal potential difference across the cell. Okay, so if VF increases, we know that the resistance of this LDR decreases, right? The terminal potential difference is the PD across these 2 points. Now, if we rearrange this circuit, that shows us something like this. This is the LDR, the fixed resistor, and the internal resistance. Let's call this R LDR. Let's call this RF for fixed resistor, and let's name it small r for the internal resistance. And we have the battery, the source over here. Now, if you connect a voltmeter across the battery with internal resistance here, in the rearranged circuit, that same setup would look like this. A voltmeter connected across the LDR and across this fixed resistor. Something like that. Now, if the voltage of the LDR decreases, overall resistance of this section of the circuit will also decrease, which means the terminal potential difference, the potential difference that is read by this voltmeter, will decrease. 3 resistors are connected to a cell of negligible internal resistance. Which circuit has a combined resistance of 25? Okay, combined resistance of 25. In option A, we have a 100 ohm resistor connected in series with a parallel network of 100 ohm and 50 ohm. And option A will definitely not be the answer, because, like, think about it. If we assume the resistance of this is 0, even if it is 0, the total resistance of the circuit will definitely not be less than 100, right? So it's definitely not going to be 25 ohm. The total resistance here, whatever the resistance of the parallel network is, it is definitely going to be more than 100 ohm, right? So the answer is not A. We have a similar situation in B where we have a 50 ohm resistor connected in series with a parallel network. So regardless of what the resistance of the parallel network is, the resistance of circuit B will be more than 50. It will be more than 50 ohm. So the answer is not B. The answer might be C. We can come back and check this out. If we look at option D, it's three resistors connected in series, 100, 150. So the resistance here is 250 ohm. Very simple calculation, just the sum of these resistances. So if the correct answer is not one of these three options, it's definitely going to be C, right? So if we calculate the total resistance in circuit C, we get 1 by 100 plus 1 by 100 plus 1 over 50. This is equal to 1 over the equivalent resistance. If we make RT the subject, we get 1 over 25 inverse, which is 25 ohm. 1 by 100 plus 1 by 100 plus 1 by 50 is equal to 1 by 25. If we inverse 1 over RT, we get 1 over 25 inverse. A cell of EMF E and internal resistance R is connected to a resistor of resistance R, capital R. The maximum power P can be dissipated by the resistor without overheating. What is the maximum value of E if the resistor does not overheat? Okay, so the maximum value of E, EMF, if the resistor does not overheat. Now, power written in terms of voltage and resistance is V square by R. In this circuit, okay, this circuit has a fixed resistor connected in series with some internal resistance, so it somewhat acts as a potential divider. The voltage V across this resistor would be V over the EMF E is equal to R over the total resistance, which is R plus small r, capital R plus small r. So the voltage across this resistor V will be equal to capital R divided by capital R plus small r, the total resistance times voltage, EMF E. So V here is equal to E times R over capital R plus small r. Okay, so power dissipated by this resistor will be V squared by R, that is E times R over R plus R whole square. If we make E the subject, we get P times R. This R brought to the left is equal to E square R square divided by R plus small r whole square. Now if we remove one of the r's here, if we divide this r with this r, we get E square times R. P is equal to E square times R divided by R plus R whole square. Making E the subject gives us this equation right here. Rearranging this equation gives us square root of P over R times R plus R. This right here is option D. Three identical resistors can be connected together in four different ways. The resistances of two of these combinations are 4 and 9 ohm. What is the resistance of each individual resistor? 3, 6, 12, and 18. Okay, so three resistors can be connected in four different ways. The four different ways are this, all three resistors connected in series, all of them connected in parallel, two of them connected in parallel and one of them in series, and two of them connected in parallel with two of them in series with one in parallel. These are the four combinations, four different ways the resistors can be connected. Okay, so now let's make a table. For the 3 ohm resistor, combination 1 gives a total resistance of, combination 1 meaning this, let's call it C1. Combination 1 gives a total resistance of 3 plus 3 plus 3, which is 9 ohm. Let's call this combination 2. If 3 resistors are connected in parallel, we get 1/3 of each individual resistor. So 1/3 of 3 is 1. That's the value of resistance of C2, combination 2, if all of these resistors are 3 ohms. For combination 3, C3, where we have 2 resistors in parallel with 1 in series, we get half of 3 here plus 3 connected in series. So half of 3 comes from the parallel network of 2 resistors. If 2 identical resistors are connected in parallel, the equivalent resistance of that parallel network is half of the individual resistances. So half of 3 plus 3, which is 4.5. And for combination 4, if we consider all of these resistors having a value of resistance R, two identical resistors connected in series has a resistance of 2R. And if we connect one more resistor with the same value in parallel, we get something like this. 1 by 2R plus 1 by R is equal to the equivalent resistance 1 by RT. Solving for RT, equivalent resistance gives us 2/3 of R. Now, if we attach 3 in the place of R, we simply get 2 ohms. Okay, so for the 3 ohm resistor, we get 9 ohm for combination 1, 9 ohm, but we don't have any combinations that results in 4 ohm, right? So let's move to 6 ohm. For 6 ohm, the first combination gives us 6 times 3, 18. And for the second combination, it gives us 6 divided by 3, which is 2. For the third combination, it's half of 6 plus 6, which is 3 plus 6, gives us 9. Now, if we plug in the value of 6 over here in the place of R, we get 2 by 3 into 6, which is 4. For the 6 ohm resistor, we have a resistance of 9 ohm for this combination, combination 3, and a resistance of 4 ohm for combination 4, which means B is our correct answer. B is our correct answer because two of these 4 combinations results in a equivalent resistance of 4 ohm and 9 ohm. Okay, so just for clarity, let's do the same for 12 ohm. In combination 1, for 12 ohm, we get 12 times 3, 36 ohm. 12 divided by 3, we get 4 ohm. Half of 12 plus 12, 6 plus 12 gives us 18. And plugging in the value of 12 here in the place of R, we get 2 by 3 times 12, which is 8. We don't have 9 or 4 here, so the answer is not 12. And as for 18, for combination 1, we get 18 times 3, 54. Combination 2, 18 divided by 3, 6. For combination 3, it's half of 18 plus 18, which is 9 plus 18, giving us 27. And plugging in the value of 18 over here, we get 2 by 3 times 18, which gives us 12. So 9 and 4 ohm is given by resistances of 6 ohm. So B is our correct answer. In the circuit shown, a battery of negligible internal resistance is connected in series with a pair of fixed resistors R1 and R2. The circuit is to be used to test whether the EMF of a particular cell is 1.5 volts. The cell is connected between terminals X and Y in parallel with R2 and in series with a galvanometer. Which statement about the test is correct? Okay, so this portion of the circuit is a potential divider, right? So the potential across these 2 points would be V is equal to the resistance of this resistor 20 divided by the total resistance of these two, 20 plus 60, 80, times the EMF, which is 6. The voltage will be equal to 1.5 volts. Now, if the potential here is 1.5 and the potential over here is also 1.5, the potential difference between these 2 points the PD will be 0 volts. If the potential difference is 0 volts, the galvanometer will read exactly 0. There won't be any current flowing through these 2 points because the potential difference is 0. Which statement about the test is correct? Any non-zero reading on the galvanometer means the cell has an EMF of 1.5 volts. Nope, because the cell has an EMF of 1.5 volts when the galvanometer reads 0. The battery does not need to have an EMF of 6 volts. Nope, the battery must have an EMF of 6 volts because if it wasn't 6 volts, the voltage across this resistor R2 would not have been 1.5. The cell may be connected either way around between X and Y. Okay, so instead of connecting it this way, if we switch the polarities like this, the current will flow in the opposite direction, right? Okay, so from this battery, if you consider this battery, the current flows in this direction and goes towards X. If we have our battery pointed this way, we have a current opposing the current provided by the battery XY opposing the current provided by the battery of 6 volts, right? The circuit works only if the battery is positioned this way. If the battery was positioned the other way around, the current provided by this battery would not have opposed the current provided by this battery. So no, it doesn't work that way. The galvanometer does not need a scale calibrated in amperes. Okay, so if these three options are not correct, that means option D is correct. The galvanometer doesn't really need to be calibrated in amperes, even if it was milliamperes or microamperes. A zero current is still zero current, regardless of the unit. An element has two isotopic forms. What are the nuclear arrangements of these two isotopes? Okay, isotope means the same proton number but different neutron number or nucleon number. Option A, they have different nucleon numbers and different proton numbers. Nope, they have different nucleon numbers but same proton number. Option B, they have different nucleon numbers but the same proton number. Yeah, this makes sense. The correct answer should be option B. They have they have the same nucleon number and the same proton number. Nope, not C either because they don't have the same nucleon number. They have the same nucleon number but different proton numbers. Nope, they must have the same number of protons to be isotopes. A hadron has a charge of plus E, where E is the elementary charge. Which combination of up U and down D works could form this hadron? Okay, so an up quark has a charge of plus 2 by 3 E, and a down quark has a charge of minus 1 by 3 E. A combination, a DDD combination, will have a charge of minus 1 by 3, minus 1 by 3, minus 1 by 3, which is minus 1 E. So it's not A. U, D, and D will be 2 by 3, minus 1 by 3, minus 1 by 3, which is equal to 0. So it's not option B either. D has a charge of 2 by 3 plus 2 by 3 minus 1 by 3, which is equal to positive 1. The answer is C. And U, and U is going to be 2 by 3 plus 2 by 3 plus 2 by 3, which is equal to 2. So not option D either. That concludes this paper. I hope all of you guys do well in your exams.